Let's have a look at this example. Derivative dy dx of a function and its application. So in example 1, they want to find the slope of the tangent to the function y is equal to x squared plus 3x minus 4, where x is equal to 2. What does this mean exactly? Well, here's the function, the graph of the function x squared plus 3x minus 4. Where x is equal to 2, just find x value 2 on the x-axis, go straight up until we meet the graph of the function here. So if we were to draw the tangent to the graph, the tangent to the curve, it would be something like this. It would be a straight line, and the question is, what is the slope of that line? Okay, let's have a look at the question again. Find the slope of the tangent, which is this line, to this function where x is equal to 2. Okay, so with algebra, this is how we would do it. First, we have to find the derivative of this function. This is a polynomial, so this is a polynomial function. We know that we can do this term by term, so let's have a look at the x squared term. We just take the exponent, move it down in front, and then decrease the exponent by 1. So the derivative of x squared would be 2x to the power of 1, but we don't have to write out the power of 1. So 2x. The next term is plus 3x is going to be the constant 3. What really happens is that it's 3x to the power of 1. We take the 1 in front, multiply it with a 3, we still get 3. And then x, decrease the 1 in the exponent with 1. And then we get 0. So x to the power of 0 is going to be 1. So this, it's easy to remember. Just any constant and then x, you're left with a constant. And then when we take the derivative of any number, any constant, positive or negative, the result is nothing. Okay, so the derivative of this function x squared plus 3x minus 4 is 2x plus 3. Well, there are many applications. One application of the derivative of a function is that this describes the slope of the tangent at any point on the line. But we're interested at this particular point where x is equal to 2. So if we substitute x is equal to 2 into the derivative of the function, we will get the slope of the tangent going through this point. Okay? So 2x plus 3, substitute 2 for x, then we get 2 times x, which is 2, plus 3 is equal to 7. So the slope of the tangent is 7 where x is equal to 2. And here we have the graph again. Actually, let's check this with a calculator and see if it's true. So start a graph, and then we have to find the function x squared plus 3x plus 3x minus 4, right? Oops, x squared plus 3x minus 4. There we go, press enter. This is how it looks like. I'm going to zoom out a little bit, just one time. Zoom out. There we go. Click somewhere in the center. Click escape to go out of this zoom mode. I'm going to plot a point, geometry, points and lines, points on. And then I'm just going to click somewhere. It doesn't matter if it's not exactly 2. I'll fix that later. Now I'm just going to click escape so I go out of this drawing mode. And then I have this hand. I just move the hand just above the x-axis, press once, press once again, and then the cursor is there. I can delete it and enter 2, and then press enter. And now the point is moving down on the curve, so x is 2 and y is equal to 6. Now I would like to have the tangent, so geometry, points and lines, and tangent. I'm just going to move over this point, and there we have the line. Press escape. I can extend the line a little bit. Oops, sorry. I can extend the line, grab it, move it down here. I can see the y-intercept, for example. You can also see the where it's crossing the x-axis. Let's see if I can grab this. No. It thinks that I'm on the line. Well, it doesn't really matter. This is the equation of the function, so or the tangent. So y is equal to 7x minus 8. We know that minus 8 is the y-intercept. We can confirm it here. And 7 is the slope. And that was our answer, right? So let's go back. Oops. So look at the PDF. So the slope of the tangent is 7, where x is equal to 2. And this is how it looks like. So we can just follow this method and be able to do example number 2. Find the slope on the tangent to the function where x is equal to minus 1. Okay, so first step, take this function, find its derivative. Let's find the derivative of this term. Move down the little 2 in the exponent in front, so minus 2 times this 2 becomes minus 4, and then x to the power of 1, or just x. The next term is plus x. It's really 1 times x here, so it becomes plus 1. And then the derivative of any constant is 0, so nothing. Now, insert the value of x, which is minus 1, into the derivative function, okay? So substitute minus 1 for x. So minus 4 times x, or minus 4 times minus 1, that's the x value. And then we just add 1, and the result is equal to 5. So if we were to draw the graph, let's check another, well, I can start a new document. Graph, let's have a look at this function, minus 2x2. Let's use, remember, use this one, minus 2x2 plus x plus 5. So now we're just going to confirm the result. And x was equal to minus 1. Let's plot that point. Click there, that's okay. Escape to go out of the drawing mode. I'm going to move the coordinates for this point a little bit to the left. Now, sorry, escape. Click here, the x coordinate, click again, delete it, and put minus 1. When it's a negative term or negative constant, we have to use this minus sign. Minus 1, and then the y coordinate would be 2 for this point. The next step, geometry. Let's get the tangent. Click somewhere here, and here we have the, let's go escape out of the drawing mode. Now we can move the equation of the tangent here. We can see that the y-intercept would actually be 7. If we continue up here, y is equal to 7, that's the y-intercept, and the slope is 5, okay? And that's the result we also got here. Now try to follow the same steps and do the exercise 1, 2, 3, and 4. And when you've done one exercise, you do the same thing with a calculator that we just did to confirm your results.